Hello everyone, last video we've ended up with drafting a web application intended to control devices, essentially creating a smart home system with a web interface. And the idea is that the web server is going to be running on the Arduino 2560 Mega R3 with the built-in ESP8266 Wi-Fi module. So yesterday, I didn't yet have the board, and today the board has finally arrived. Well, essentially, it arrived yesterday, but today I started tinkering with it. So it's not trivial to get started with a board, although it has appeared for about like 3 years ago. So I just want to walk through the steps I've been through in order to save your time. Because I spent like more than 5 hours already to set up the very simple web server running on my Arduino board. I'm not showing you the Arduino board because the poor camera would not reflect everything as good as this nice picture. So this is essentially how the board looks, and there are a few steps that you need to walk through in order to get started with the board. So if you just try to use it as a regular Arduino board you just try to plug it in and try to write a sketch on it, most likely you would not be capable of doing this because you would not even see the board being connected to a computer. The reason for that is simple. Since this single board has two devices, the Arduino itself, like essentially by seeing Arduino, I'm in this chip 80 Mega 2560, where the sketch is being uploaded, where you have the built-in RAM, all the stuff. So sketch is being uploaded in here. And also there is the Wi-Fi module, ESP8266. I guess this is the chip because there is an antenna there. So I'm not sure. Anyway, and if I'm not mistaken, this chip is responsible for the USB to serial conversion, CH340, which is also quite important. So here you have up to 8 DIP switches, and they say the very last one, the switch number 8, is not used, but the 7 are actually used. They are paired switches for RX and TX, receiving and transmitting the data. And there are some modes that are available. And without getting familiar with the modes, without understanding how these modes are actually working, most likely nothing will work. However, if you put some time and effort and try to get clear with this mode, as well as with this switch, which allows you to switch between the hardware 00 and hardware 03, which allows the interconnection between the 2560 Mega and the ESP8266. So this is like as if you had a separate Arduino 2560 Mega, and then you wired, not wired, maybe just connected via the pins, or maybe via the serial connection as well. If you connected the separate module ESP8266 to it and try to run some sketches, that's sort of a similar thing. But the benefit is that you don't need to do any circuit workings, so it's already like being there. Instead of trying to wire up something or trying to connect something, you can just make use of this DIP switches as well as this switch between the RxTX0 and RxTX3. So this is it for the introduction. Now let's go to the documentation. I found a nice resource online. It's available on GitHub. I'll give you all the links in the description. So this is the table that tells us how to use the switches. So depending on the particular combinations of switches, we can achieve different behavior. So I will now talk about everyone in particular in details, at very least where I tested things, where I understand things, because still quite lots of things to explore there. Okay, so the first one, CH340 connect to ESP8266 in order to upload the sketch. So CH340 is this chip, and it's responsible for USB to serial conversion. And again, you need to make sure that on your target computer you have an appropriate driver for it. I'm on Linux. I have CH341 kernel module, which is already been there on my Linux Mint system. So I didn't need to deal with that. But if you don't have a driver, you might have an issue like not being capable of recognize the device. Also, at first I started with a broken cable, so that I also had issues connecting to my board. So something very simple that you would never be having any issues with other boards. But since there are many things that may get you frustrated, like you don't know whether the problem is within the switches, how they've been set up, or within this TX, RX TX switch here, what's wrong there, or maybe that's the cable. So too many overwhelming things. So I just try to make it simple so that you don't follow the hard path like I just did. So CH340 connected ESP8266 with an idea to upload the sketch. So the idea, if you want to have the, say, web server or access point or whatever, well, essentially you want to have Wi-Fi. Essentially, the very simple task probably, you want your ESP8266 to be connected to the existing Wi-Fi network. So this can be done. There is a specific library which we'll talk in a minute. But the idea is that Arduino Mega 2560 is not capable of directly interacting with Wi-Fi. It interacts with the ESP8266 via the serial port, and the particular serial port number is the hardware serial 3. Hence the switch, this switch. So we'll talk about the modes. We'll talk about how to put it just in a moment, right? So there are two sketches essentially up and running. So one sketch is running on the ESP8266, and that's not the web server. I will now say what is there. And another sketch is running on your Arduino, like you normally upload the sketch to your Arduino. All right, so what kind of sketch do we have on ESP8266? So there is such a thing called AT commands. So that's sort of a textual commands that you can use in order to set access point mode for your ESP8266, or the mode as a client, Wi-Fi client, to connect to existing Wi-Fi network, etc. But you don't really need those commands to learn those commands or to use those commands, because those commands are implicitly implemented already in the corresponding library, which we will get to quite soon. So, but in order to make that library work, you need to make sure that you have a proper firmware within your ESP8266. I was wondering maybe there is some preloaded existing one, but when I checked that out, I didn't quite find any. So in my particular case, well, maybe depending on vendors, because similar boards might be distributed by different vendors. So they are essentially the same, but firmware might be different. There might be some differences essentially. So the step to upload the firmware that teaches ESP8266 to talk via the AT commands is the essential step. And that's the very first step to consider if you want to work with Wi-Fi on your Arduino. Okay, so here is the schema on how you need to put the switches on. And also there is a video that essentially shows this, like with a camera, the guy shows how he does things. And essentially after following this video, I managed to set up everything. But since the video only demonstrates how to do things but doesn't quite explain pretty much anything, I decided that I can just add some explanation so that this video just shows what to do and how to do. And my video will hopefully provide some explanations. So in that video, the guy sets the dip switches this way, right? And then also, which is quite important, he sets this switch from RX3TX3 to RX0TX0. So when you want to flash your ESP, oh my goodness, I'm forgetting the number, your ESP8266, when you want to upload this AT commands firmware in here, you need to set up the switches properly. You use the first line for this purpose. Okay, then you set this switch to the location RX0TX0. Then you connect this to your computer, and you need to figure out what kind of port is that. But again, I'm now just telling you about the contents of this video. You can look at this on your own. So then you need to use the ESP tool, so-called, which allows you to, since this is the ESP board, it's not Arduino, it's ESP sort of a thing. They have their very own software in Python that you can use in order to upload the firmware. And you also need to download the firmware. All the links to the firmware and to the ESP tool itself are available on the description below the video I've been following. So hopefully that makes sense. Once that is completed, you then may want to test whether you have uploaded your AT commands properly or not, whether the firmware has been uploaded or not. Because later on, when it comes to debugging the server, you might say like the server is not working for some reason, you don't know why, is that the firmware or something? So I will now show you how to debug the AT commands. Then once you get done with those AT commands, you can then upload a sketch into your Arduino 2560 Mega, and I've uploaded the web server. Particular, the guy in the video uploaded the test to search for Wi-Fi networks. I've uploaded the web server so that I can access the web server running on my board. That's exactly the case I've been looking for, because again, I just want to control Arduino output pins and input pins by the web interface. Hence, I need the web server. So web server is running on Arduino, but it transmits the data with the ESP8266 using the serial hardware serial 3 communication. For that sake, you need to switch this back. We'll get to this. So I will not be showing you what am I do, how am I switching the switches, but I will mention the particular schemas that I will be using, and then I will now run the tests to sort of show you how things are actually working. So let's probably kickstart it with running the Arduino IDE. Also on Linux, for those struggling with this stuff on Linux, to make sure it works with the latest Arduino IDE, you need to make sure that the proper permissions are given to the current user you're logged in as, so that it has an access to the /dev/USB TTY1 or USB TTY0, depending on what port you're using. Because if it belongs to the root user, it's not going to work, because you cannot run the latest Arduino as root. It just crashes and not working. So make sure to switch the permissions properly. Okay, so now we should select the board. So at the moment, the board is in the mode like the web server is now running. So 2560 Mega, and okay, and I just go to serial monitor, and here is what's happening. So it just connects. So don't look at this. It's just some garbage that I've added to make sure that I have the updated version here. So essentially, it walks through the initialization. It connects to the Wi-Fi. You are connected to the network, so the SSID. This is the SSID of my Wi-Fi, and this is the IP address that my Arduino gets. And the HTTP server runs exactly on this address at port 80, as mentioned here. You probably can use another port. I didn't yet try this, but yeah, we should sort of have a look at that. Now, if we go to this particular location in the web browser, so I just go exactly there, and we have this hello world received requests 1, and in the meantime, within the Arduino, if I just minimize the window a little bit here, It says like send in response, so client connected, client disconnected. Well, I'm not quite sure about the connection state. This is another big topic to discuss, but at the moment, if I just make this always on top, so if I just if I update things, you see it sends the data sets, the headers. So it's sort of alive. And again, counts how many times the web server has been requested, like from the outer one. I can also, for instance, use my smartphone if it's connected to the same local network. I cannot do this because my smartphone is now recorded. It records in the sound, so I don't want to mess up things. But again, whatever device that is connected to the local network can get there. Furthermore, one day, if I want to make this available from the outside, let's say, I will probably need to forward the ports on the access on the router. But again, that's sort of another topic. And also, by the way, this server automatically updates every 20 seconds or so. It's mentioned within the code. All right, so since we've started with this web server code, after you have installed the Wi-Fi ESP library that can be installed just like any other library under the Arduino IDE, there is a web server sketch. So I just open this sketch now, just to give an idea what should be changed. So after updating the firmware with a particular binary that mentioned in the video I've been mentioning, there need to be some changes needs to be done there. So the first change you need to set the baud rate from 1900s to 115200. That's essential, otherwise it's not going to work. Another extremely important thing is that you need to use serial 3, not serial 1. And also here Wi-Fi init and pointed to the serial 3. So this one should be this should be 3 essentially, and as well this also should be 3. And this should be like this. After you can upload the sketch into your Arduino, and you will have exactly the output that I have now in my web browser. So hopefully that makes sense. So this is the simple part, I believe. But also there is the hard part that is like how to. You also can talk to ESP8266 directly via the serial monitor. Before we get there, I just want to show you one more thing that I promised to, but apparently forgot to show, is the following. So to make Arduino Amiga 2560 interacting with the ESP8266 that is responsible for connecting to Wi-Fi, you need this first line. Oh, sorry. Whoa. Nope. This one. Yeah, you need this line. So currently on my Arduino, following switches are being set up. So this is here they have one here and a here. I have them absolutely vice versa, or not. No, I have them the same. Yeah. So 1 on, 2 on, 3 on, 4 on. Others are off. And also this switch should be at the location RX3TX3. In this case, assuming that the sketch that I've just demonstrated is uploaded in here, and assuming the firmware is uploaded in here, we have the web server up and running. Now, if we want to talk to, now let's say we want to upload the firmware to ESP8266. In this case, you need to use the following line. You need to use the first line, this one. But with this line, you would not be able to communicate via the AT commands with the ESP8266. In order to being able to communicate, you need to use this one. So one switch is off. And for both of these lines, it's very important that this switch is set to RX0TX0. So when you want to either update the firmware of the ESP8266 or you want to test the AT commands, switch should be turned to RX0TX0. If you want to run the web server, then your Arduino needs a way to communicate with the ESP. So in this case, RX3TX3. So I will now change the dip switches on my particular boards to this state. You can also, there are two ways how you can do this. You can just turn the device off and get the adjustments and turn it on again, but also you can switch the dip switches and then click this mode button and then reset button. And in this case, it's safe to change the mode sort of on the fly without particularly powering off the device. That's mentioned in the instructions, so that's fairly safe. Okay, so I will now set up the dip switches accordingly. So all those I have on are just off everyone, and then switch. Oh my goodness, I forgot which one. 5 and 6 to on. So I'm setting 5 to on and 6 to on, and RX0TX0. Okay, I get things done. Now I press mode, and now I press reset. And you see it has updated, so it no longer prints the web server stuff. Instead, it tells me AI Thinker Technology Company Limited ready. And here I essentially can send the AT commands. Need to make sure that a new line character followed by the carriage return are sent, and the baud rate is 150 and 200s. So if I say, let's say AT, it says OK. If I say AT plus GMR, it prints me the firmware version, and other commands are also can be you can input other commands as well. So hopefully this makes sense. So again, we are in the mode. I'm not sure why it's flickering, to be honest. Looks a little bit strange to say the least. Okay, anyway, you see, like, it's there anyway. So you can interact with these commands. In case if you might get frustrated, then if you have also this switch on, if you, this is needed when you want to upload the sketch into the firmware. In this case, you would not be able to communicate via the AT commands. So that's another important thing to consider. Now I will drop the dip switches back to this configuration. Okay, so let me quickly do that. And yeah, by the way, now the server is broken. See, like, it's broken now because it's in the wrong. The board is in the wrong mode. So I just bring everything back as it was. So I set 1, 2, 3, 4 to on, and RxTX to serial 3, and I click mode, and I update the board. And now it should tell me that, again, the web server starts running. So after all these AT commands, you see, attempted to connect, then starting the web server. So again, it just gets back to the web server mode. And here, you see, like, automatically it has fetched the data from the web server that is running on my Arduino board. So yeah, guys, this is essentially it. Again, I'll give you the links to the resources I've found in the description below the video. And again, this video is a very, like, a shortcut for what I've just tried to explain, how to do things. Different operating systems, it might be like a different setup, but I didn't find I couldn't find anywhere this clear explanation on what is what, essentially, and just divide and conquer things to make sure that I can debug everything in separate. Like, I had an issue with the cable, and I didn't have an idea whether that's the cable issue or the dip switches issue or the firmware issue or the sketch issue or what kind of issue that in order to upload the very simple blink into my Arduino, assuming this particular board, it took me like a few hours to figure out like what's essentially going wrong there. So hopefully this makes sense. And again, as for the other, so we've covered this one. So if you want to update the firmware for ESP8266, this one, if you want to run the AT commands, connect CH340. Again, this is like the USB to serial converter. I didn't try this. I have no idea what this makes in particular. So essentially, this is probably needed if you want to upload the sketch to Arduino Mega without without considering this 8266. That's just my assumption based on what is written there. Now this, if you want to have both, if you want to be able to upload the sketch to 2560 Mega, and also serial port 3 is connected to ESP8266. If you want to do a web server or any Wi-Fi related project, then this is your configuration to run things after you've done this. Okay, and finally, this one, I'm not quite sure, but I can assume that in this position is the same as this one, but you simply cannot upload the sketches. That's just my assumption. I'm not quite sure. And as for all modules work independently, when this configuration didn't work for me at all, so I have no idea if this is useful or not. And again, as for the switch between TX, RX 0 and 3, in this case, it should be equal 0. And in this case, or maybe in this case as well, but when you eventually running things, it should be in position 3, so that your Arduino 2560 can communicate with your 8266 via the serial port 3 hardware serial port to make sure that everything works properly. Oh my goodness, yeah, this is from my side. So hope you've enjoyed the video and found something interesting in it. Next step is to connect the web application that I've written in the previous video with this web server running and try to control the built-in LED from the web interface. That's the next thing I'm supposed to be trying to do. And there will be another video dedicated to that topic. And for now, that's it from my side. So again, guys, yeah, thanks for watching. Sorry for too many words, but I just get so frustrated, so overwhelmed to make things work. But once you get into it, the benefit is fantastic because you can control your Arduino from the web interface. That's freaking amazing. So yeah, thanks for watching. See you later. Cheers.